Okay, so what we're going to be presenting today is going to be practice 19, and I'm going to be showing you right now in just a second. This practice is going to be a milling process, and we're going to be using it in the DOSBox program. And it tells us that considering the measurements in the attached drawing, please generate the necessary CNC code for the manufacturing parts. Now, we have to exercise caution regarding the cutting tools and tools that we can seem appropriate. So any missing corner for the finishing due to the diameter of the primary cutting tool has to be used to remove 1 millimeter of the diameter cutter. We should not exceed more than 1 millimeter for each cutting grass. Now, as we can see, this piece is going to be of the UPPN, and this part we're going to be establishing the measurements. Now we can see that there's a height of 70 and a longitude of 146. I added that by summoning the rest of the measurements that we have, and on top of that we can see that the depth that it has coordinated. Now I'm going to be showing you the program, and if you don't know yet, I have it established right here. First of all, this is the DOSBox program. We're using the milling process, and we're going to be explaining a little bit of the things that I'm using. So first of all, billet. What is the billet? So billet is basically the thing that we're going to be establishing and where we're going to work as. So it's basically just giving the measurements of the piece, and I established that we are going to have X, which is the longitude, in 146, Y, which is the height, in 70, and Z, which is the depth, in 25. Now, edge move, what is it? So edge move is basically that I don't want the piece to move. We can add that just in case something goes wrong and maybe the tooling moves, and we just basically established it in a really secure position. Now, I define my tools right here. I have tool depth, basically, and I have 1, 2, and 3. Now, we really, to the difference of actually the other process that we use in the other programs, it's just basically telling me that tool 1 is going to use a diameter of 9, tool 2 a diameter of 4, and tool 3 a diameter of 1. Each one is going to have a depth of 15. After that, we're going to go with the G codes. Now, if you don't know what G codes are, I showed you in the beginning, and these are a list of the G codes that we have. So the ones that we're going to be using right now is going to be G21 is the first one that we're going to see. It programs the coordinates in millimeters, as we can see here. Now we're going to go with G90, as we can see right here, and it's another coordinate system, and we're going to go right here real quickly, and it's the absolute program of X, Y, and Z. Then there's G95. Basically it's the motion code for units, revolution, feed mode. Now, after that, we're going to go watch what is G28. Basically, this is just securing the home position. After that, we have the M codes. So, M codes, I have established that they're basically just like commands. So, in this first one, it's commanding that we bring the tool number 1, as we can see here. And M03 is establishing the start of the spindle. So it's just that. Now, as we can see, we start off with the piece right here, and we have to know how to start. So as we can see right here in the corner, we have 13, but we're gonna add a total of 4 units more because of the diameter that we're working with. We're going to take half of it. So the half of 9 is 4.5, and that's what we're going to be starting with. So 13 plus 4.5 is going to actually be 17. I actually have it around right here. I started at 16. We'll be fixing that later. So it starts off with X16 with a height of Y, which is 46.5. If you're asking yourself why, we have a total height of 15 on the first part right here, and we're going to be subtracting, which is going to be the 4.5 of that. So after that, I actually created sub-programs for each and every one of these of this program. I created UPPN differently and separately so that I could just go ahead and put them all together. but we're going to be watching the full program right here. So first of all, I'm going to be showing you the whole process. What you have to do is always secure control page up, basically meaning that you always have to be towards the top of the program, because if you're not, then it's probably not going to run well, or it is, but it's going to run real quickly. I'm going to show you first a real quick way of how I finished my piece, but then we're going to be watching how it is made one by one. So all you have to do is put function F9. We're going to run the program. We're going to see it real quickly. As you can see, these are the sub-programs that I have made. Each one of them has a cycle of 10 cycles, making the perforations of the actual piece, because I wanted it to be as neat as possible. What you're seeing here, right here in the yellow lines, are the contours. So in the piece where the pieces aren't actually straight, they're squared. So at the end of the piece, this is what we're gonna have. Now, if you really didn't capture everything quickly, it's okay. We're gonna be passing it once again, but now it's gonna be slowly, and we're gonna be watching the whole process. So there you go. It starts off with the spindle. We establish our first coordinate, and it goes to the subprogram of U. Like I said, it started at 17.5. I actually had it wrong in the first part, and it's going to go up to Y33.21. Now, if you see that we have G03. So G03, remember that it's actually we're going to be over here. We're going to go back over here, and we are going to be seeing what does it mean while the program actually is running. As you can see, it's going to take a long while, so we can go ahead and see. G03, so basically this motion is counterclockwise to the circular arc, and we have established that it starts off at 38.5, which is the things that we added, and it has a radius of 10.5. We can see here in the piece that the middle part, which is right here, is a whole diameter of 15. So we're just gonna take half of it, and then we're gonna add 4. So as we can see, it's gonna keep running, and we're just gonna keep watching it. So it's actually going on the 5th cycle, and we're going to be explaining each and every one. We have G03 in the counterclockwise, and then we have G02. So G02 is the clockwise G code, so we can make that radius. M99 basically just means that the program has finished, and we're just going to be continuing watching how this advances. So as that advances, we're going to be just watching the piece continue slowly, and I'm going to be explaining each and every one of the process. So we're going to be starting, and it's going to keep going. Now we're in the 8th cycle. After that, let's keep continuing. Let's keep going, and there you go. It's going to go on the 9th cycle. It's going to finally finish the first U. That's basically, it just goes to the depth that we defined as 15. So there you go, the last cycle. We go back to the main program. We push to the next start of the second program, and we're going to be starting quickly on X47.5, and here is the radius that we have. As you can see, the P actually doesn't stop. It actually goes the full circle, and that's because I didn't add X or Y, defining that I actually had to cut that radius. So it's a full circle basically. It finishes at Y35, which is the height, and it also has a small the small little leg of the P in Y18.5, and we still have M99, basically just telling the program that this is a subprogram that I want it to finish. So we're going to keep going, and we're gonna keep, it's in the 5th cycle, it's gonna keep running, and we're gonna be continuing to finish this program until it's completed. We actually have 2 P's, so it's basically the same thing. Each subprogram is the same. We have G91, basically just defining which is the G code I'm going to be telling you right now. We're going to go ahead and search it up right here. G91 is the coordinate system. There's 2, but it's just basically the incremental programming of X, Y, and Z. And we have the absolute programming of X, Y, and Z. So it's just showing that, oh, there you go. We're starting the 2nd P. Remember, it's the same process. G91 is the absolute programming, and G90, it's the absolute programming of X, Y, and Z. So we're just defining the processes that we're making. Again, it starts off on G02 with the clockwise circle completed and with a radius of 10.5. We're going to be finishing off on M99. Again, it's telling the program that it has to finish, and it has an altitude of Y35. It's the same thing as the last P, so we're going to be continuing to watch it. If you want to continue watching a little bit more of the G codes, we're going to be here on the page. So after that, it's on the 5th cycle. It's going to go to the 6th. There you go. And we're just going to be waiting a little bit more for the 8th cycle of this part we're going to be making. So just the 7th part. Now we're going to go 8th, then 9th, hopefully. It's going to be a little bit quicker. I showed you the first process, which is a lot quicker than this, but now we're going to be seeing it into more depth. Alright, so there you go. We're going to be the 10th process. We're going to pass on to X, and it's going to start on X107 with a height of 24.5. We go to the subprogram, as you can see. Now the N, the height starts at Y35 as U, and the X starts on X107.5. It actually moves to a X28.5, which is going to be the starting point to the end point with a radius of 10.5. So just defining that arc, and we have the counter and clockwise orders that we have. It ends at with the counterclockwise, it just returns back and forth. That's all it has to do. So we're going to wait for the 10 cycles. After that, there's going to be a really fast process for the counters. The contours basically is just giving the letters a squared finish, because once we make the letters, because of the circle movements of the milling, they actually end up rounding, but this piece is telling us that we wanted it squared. Now, it also stated that it had 1 millimeter of diameter of, let's say, a preference, right? So we don't want one more and we don't want one less. So after that, we're going to be waiting just a little bit. It's going to the 6th cycle right now. And we're going to be watching this really fast process. I'm going to be showing you the 3D piece of it too, so you can actually define for yourself how it's finished and how we can see this part. So it's going a little bit more. It's taking quite a long time actually, and hopefully we can finish this. We can establish this routine. It's going to the 8th, hopefully. And now we're going to the 9th. It's going right now, right there, a little bit more, and there. Alright, so this is going to be the last cycle. Pay a lot of attention to the next process, because it's going to be a flash through your eyes. I actually have another sub program, but basically it's something really simple. I'm just establishing the coordinates of G90, and there you go. That's really quickly the process. We can see the sub programs right there, establishing that what I want to contour is making the each rounded piece into a squared. And there you go, it's finished. Now we're going to be watching this piece in 3D. I'm just going to press my function 9 3D view, and I have it right here at a half point because that's how I established it. But here with my little friend of the blue sign right here, the blue triangle, I'm gonna make the piece go faster. So I'm gonna go back to my piece so you can see it completely. I'm gonna run the program right now, but I'm gonna cancel it right here. If you don't actually make the whole piece, once you press the 3D piece, you're not really gonna see it. So you have to make the program, you have to run the program again, and you can start it at some point after N60, and it's gonna go really quick. So I decided to just start on the piece so it can go real quickly and we can see how the U is made. Actually, I think I have to cancel that because since it's not actually cutting the U, I have to start it again right around here. It has to be after the spindle, and there you go. We're gonna run the program. The U is established real quickly. This is what I did in the beginning just so you could see how the piece is. This is the 2D version of the piece. It's going real quickly. There you go. And right around now, it's going to be with the contours, making those round pieces squared. And there you go. Each and every one of them has a process of 10 cycles. Now we're going to go back to the 3D view, and we're finished. So this is our whole piece. I actually can't move it so it can show you how it's supposed to look, but this is a SolidWorks version of it. And as we can see right here, UPPN, UPPN. And that's about it. So thank you so much.